This podcast is on stoichiometry calculations, ending with a discussion of percent yield and percent error. In working a stoichiometry problem, the first thing you need to do is identify the reactants and the products and write the balanced equation. You ask yourself, what are the reactants and what are the products? And you get that from reading the actual question. Then you need to go ahead and balance the equation, making certain that the number of atoms on the left equals the number of atoms on the right. Once you have your balanced equation, you then need to determine the moles of that which you are given. So we go through and calculate that we have 0.2739 moles of aluminum using the molar mass of aluminum. Notice the units are canceling. We then go ahead and determine the moles of aluminum oxide that would be formed by the complete reaction of all of our aluminum. And we get 0.1370 moles. And theoretical yield is in fact a mass, and so to determine the mass of aluminum oxide formed from the moles, we go through and multiply by the molar mass of aluminum oxide, and you get an answer of 13.96 grams. Now, remember your sequence. This is the same for every single stoichiometry problem. You need a balanced equation, you need moles, and if you're given mass, you have to do the conversion. Find the proper mole ratio from the balanced equation, use that mole ratio to calculate the moles of what you're looking for, and then convert moles back to mass if that indeed is what you're asked for. Percent yield is a common lab calculation. So let's say we were in the lab and we wanted to find out how good we were. We would use this formula. Percent yield is actual over theoretical. Another calculation that we might do is called percent error. That is where the theoretical yield and the actual yield are subtracted, and then you divide by the theoretical yield and multiply by 100. Let's look at an example. In that previous stoichiometry problem, we expected to produce, or had a theoretical yield of 13.96 grams of aluminum oxide. When we measured the mass of the product on the balance, we determined that we had recovered 11.47 grams. So we need to calculate our percent yield. The percent yield is the 11.47 grams divided by 13.96 grams. Multiply all that by 100 and we get 82.16%. That would be our percent yield. Our percent error could be 100 minus that, or, in fact, using the exact same question, it would be the 13.96 minus 11.47, so that's the amount we're out by, divided by 13.96 times 100, and we get 17.84%. So percent error and percent yield are two calculations that you can do if you know the theoretical yield, and that is what you would produce if all of your reactants were converted to products.